Hello everyone. Today we will continue to do some geometric series. In the last class, we get the conclusion that for geometric series, when the r absolute value less than 1 converges to a over 1 minus r. For r absolute value greater or equal to 1, the series diverges. Right? So today we are going to do more problems by using this. Let's see, example 1. The geometric series with a equals 1 over 9 and r equals 1/3 is this one, 1 over 9 plus 1 over 27. This is geometric series is given. I may just hide all those things. Okay, if it's not given, we should know what is A, what is R. So let's see, what's the sum? Okay, geometric series. Let's see. From this one, we can see A is 1 over 9. What is R? We said you can use different way to find R. I like to use my second term divided by the first term. So I get my R equals 1/3. And I noticed this is less than 1 converges. That means there is sum, right? And what is the sum? The sum I can write down 1 over 9 plus 1 over 27. The series, the sum equals A over 1 minus R. And what is A? Just plug in. R, 1 minus 1/3. Simplify. 1 over 9 divided by 2/3. I cancel them. Oh, you can use 1 over 9 times 3 over 2. Either way. So my answer should be 1 over 6. Oh, you can do the other way. 1 over 9 times 3 over 2. And then you cancel the 3, and you get 1 over 6. Same thing, right? Either way. So this is how you find the sum, just by using the formula here. A over 1 minus R. Let's try this exercise problem. Let's see if this series converges or diverges, and if it converges, what is the sum? You can do this problem by yourself. Now let's try. I'm going to give you the solution. When you do that exercise, you can pause my video. A equals 1/2. R equals 1/2. Converges A over 1 minus R. 1/2 over 1 minus 1/2. 1/2 over 1/2. What? The sum for this series is 1. Okay, let's take a look at example 2. N from 0 to infinity, -1 to the power n, 5 over 4 to the n. This geometric series actually is given by the general form an. We don't know what is A, what is R from here, right? But we can see, we can write out our first term. So be careful. N start from 0 for this case. So we let n equals 0, plug into our an. So what is, let's see, what we want to see what is our first term. That means -1 to the power 0 because n start from 0. 5, 4 to the 0, anything to the 0 power is 1. So -1 to 0, 4 to 0, they are all 1. So the A is 5. After we find the A, we should find our R, right? There are two ways to find R. The first way, you can see what is our geometric series, A, R to the N. So from this series, you can see R equals -1 first, because we can write our series as combine the -1 and the 4 together and put the N to the outside. So this is like A, and this is like a R. That's the first way to find R. The second way to find R, you can write out your next term. So when N equals 1, your next term will be -1 times 5 over 4. So -5 over 4 is your next term. So your series will be 5 minus 5 over 4 plus whatever. Okay. And then you use the second term divided by the first term. It's also -1 first. You can decide which way you like. Okay. For this problem, maybe the first one is better. I'm not quite sure which way do you like. You can pick any one. Two methods. 1 and 2. Okay. So the sum for this series is A over 1 minus R equals, plug in. A is 5. 1 minus R is -1 first. Be careful, put the parentheses. 5, 1 plus 1 first. 5 over 5 first. Cancel out. 5 times 4 over 5. Final answer is 4. 4 is the sum. Okay. Now let's try some exercise problems. The first one, 9 over 100, 9 over 100 squared. Okay. The second one, 1 minus 1 half, plus 1 first, minus 1 8. Number 3. And start from 1 to infinity. 91 to the n, 3 to the 4 to the n. 3 problems. And you can check. Those 3 sequences, series, they are all geometric series. So here we want to use the formula A over 1 minus R. For the first series, we know A equals 9 over 100. A is always the first term. And from the series, we can see R equals, for this case, 1 over 100, right? So plug in A over 1 minus R equals 9 over 100 divided by 1 minus 1 over 100. 9 over 100 divided by 99 over 100. Cancel the 100. And 9 over 99, cancel the 9. The final answer should be 1 over 11. That's the sum. For the second one, A equals 1. R equals -1 half. Plug in. A over 1 minus R equals 1 over 1 minus 91 half. 1 over 1 plus 1 half. 1 over 3 half. 3 over 3. 2/3 is the final answer. The last one. A, the first term we don't know, but we can find our A. And be careful, this n start from 1. So I plug it in, n equals 1, so it should be -1 times 3 over 4. So my first term is negative 3 over 4. And r, same thing, I can combine them into negative 1 over 4 and to the n and then times 3. And my r is negative 1/4. Plug into the formula. A over 1 minus r equals A over r minus r. Here 1 plus 1/4. Here just algebra. Cancel the 4, negative 3 over 5. That is the sum. So those are the solutions for the 3 exercises problems. You can try those by yourself. We can stop here. Let's see the next. Next, we will look at the telescoping series and what's the sum of that kind of series. Example 3. Find the sum of the telescoping series. The series look like this form. Let's take a look. N times n plus 1 here, n from 1 to infinity. Okay, we want to find the sum of this series. Why it's called telescoping, I'm going to show you now. Firstly, for this term an, we want to use partial fraction to separate this into two terms. Partial fraction composition method. We learned this in Calc 2 when we try to find the integral of something. We separate the term. So Calc 2, when we learn this, when we have some integral like this, x plus 1. When we try to find the integral of this, we do partial fraction, right? We can do a brief partial fraction here. So for the partial fraction, we make a on top of one term and b over the other term. And now we combine them together. A times n plus 1 plus bn. And now we let numerator equals numerator. So let's see. We simplify a times n plus 1 plus bn. So it becomes na plus a plus bn. And we set this equal to 1. And now we solve for ab. And from the equation, we can see if we pick all the n term, that is a plus b times n. We factor n out. And for the constant, that's just a. And now we can set up two equations. A plus b equals, right side of the equation, there is no n, so a plus b should be 0. And what is capital A? A is 1. And then this is two equations with two unknowns. We can solve for AB. A equals 1, B is A plus B 0, B definitely it should be negative 1. So our series becomes what? Our series becomes n plus 1. Here we separated this into two terms. So into a over n, so 1 over n minus 1 over n plus 1. This is our series after partial fraction, right? So for this kind of telescoping series, we want to find our partial sum at Sn. Okay, we do different way. So partial sum for this case should be 1 minus 1/2. That is the first term. You can see if we let n equals 1, that is our a1. And then plus a2. a2 is what? N equals 2. 1/2 minus 1/3. And plus n minus. This is our n's partial sum, right? Now simplify. We have negative 1/2, positive 1/2, negative 1/3. They all cancelled actually. Let's cancel with the previous negative 1 over n. So as n equals 1 minus 1 over n plus 1. And this limit goes to 0. So 0 is the sum of our series. That's the definition for the sum of series. That's the limit of the partial sum. So 0, right? And here you can try the exercise problem. So here I give you 2 problems. The first one, you can see 3 over n squared minus 3 over n plus 1 squared. Okay, for this one we don't need to do the partial sum. This is already given. The second exercise problem will be this one, n from 1 to infinity. For the second series, we can see we have only one term an, so we need to use partial fraction to separate this into 2 terms. Okay. So here's the solution. But it's better for you to do this by yourself before you look at my solution. The first one, Sn, 3 minus 3 over 2 squared, and then plus next term 3 over 2 squared minus 3 over 3 squared. You don't need to simplify. We just want to write out the first several terms and then the nth term. And then we cancel all the middle term. That's why it's called telescoping. They all cancelled. So Sn equals minus 3 over n plus 1 squared. And the this limit goes to 3 when n goes to infinity. So the sum of this series is 3. The second one, partial fraction. A over 4n minus 3 plus b over 4n plus 1. Combine. Numerator equal to each other. Get 2 equations of A and B. Here I pick the coefficient for n, which should be 4a plus 4b. On the right side, no n term equals 0. And then look at my constant on the left side of the equation. My constant should be a minus 3b, which is 4. And then solve for ab. So solve for ab, there are several ways. You can do substitution method, you can do elimination method, right? 2 equations, 2 unknowns. You can use any method to solve. For example, if we do substitution method, so a equals 3b plus 4, plug into the first equation. So 4 times a, which is 3b plus 4, 4b equals 0. So it's 12b plus 16 plus 4b equals 0. That means 16b plus 16 equals 0. B plus 1 equals 0. Capital B is -1. Capital B is -1. A is -3 plus B. So A is capital 1. So we get, this is a partial fraction. You can review this. Okay. So our series becomes what? A is 1. 1 over 4n minus 3 plus 91. Oh, here we can just write down B is -1. So we write down minus 1 over 4n plus 1, right? N start from 1 to infinity. So partial fraction equals what? Plug in n as 1 for the first term. So it should be 4 times 1 minus 3, 1 minus 5. Okay, this is the first term. And then the second term, n plug into 2, 9. You can just write down the first 2 or first 1 term. That should be good. As n, and then cancel all the middle terms. So the limit goes to 1. So the sum of this series, can write down, is just 1. Okay, this is how we find the telescoping series sum. Partial fractions. We can stop for finding the sum of the series. Now we are going to find the sum of other general series. Before that, let's take a look at theorem 3. So this gives us some sum of the series, some rules for the series. Let's see. If the sum of an is capital A, sum of bn series which is capital B, they are all convergent to that series. Then we have the first is called the sum rule. You don't need to know the name, okay? We just need to know what's the meaning. If we add a and bn together, and this series just equals, we can separate them into series an, series bn, and the sum will be capital A plus capital B. The second one is called the difference rule. Difference, that means an minus bn. And the same thing, separate them, and which is a minus b. The next one is constant multiple rule. You can guess, actually it's constant, k times an. This equals k times capital A. Something like that, right? And the proof is pretty easy. We skip the proof, but if you want to see, I can give the first one. The first one as n equals, you can see an plus b1 and a2 plus b2 for the first series, and plus an plus bn. And now we combine all the an term and bn term, which actually give us a and partial sum for series an, bn, and it goes to a plus b. Right? That's the proof, but we don't need to know. We can just use the result to find the sum of other general series. Example 4. Find the sum of the series. Okay, the first one. n start from 1 to infinity. Let's take a look at this one. This series is not geometric, O is not, and it's also not telescoping. So how to find the sum? So firstly we want to simplify. We separate this into two terms, which is 3 to the n minus 1 over 6 to the n minus 1 minus 1 over 6 to the n minus 1. Okay, separate this. And now simplify this term. 6 over 3 should be 1/2, right? So after we simplify, so it should be this term. Okay, and minus 1 over 6 to the n minus 1. Are you okay, everyone, for this term? If you don't know how, you can combine 3 and 6 together. Take the n minus 1 out, and 1/2 to the n minus 1, and then it's 1 over 2 to the n minus 1. That's the detail step. And now we get two geometric series. They are all geometric series. And let's see what's the sum of them. Do you still remember what's the sum of geometric series? A over 1 minus r, right? For the geometry. And what is A for the first term? That is the first term. We plug n equals 1. So it should be 1 over 2 to the 1 minus 1 power. So it should be 1 over 2 to the 0 power. So it should be 1. All right, that's the first term. And the 1 minus r. Can you see what is the r for the first geometric series? Should be 1/2, right? And the same thing for the second term. The first term a should be 1, and the ratio r is 1 over 6. Now simplify. 1 over 1/2 minus 1 over 5 over 6. Should be 2 minus 6 over 5. And simplify a little bit. The final answer going to be 4/5. Okay. Now you can try this. I'm going to give you another one and then give you the exercise. This one. This one, you can look this as 4 constant multiple rule. 1 over 2 to the n. And then this is geometric series. The sum is a over 1 minus r. The ratio r is 1/2. What is the first term? Plug in n as 0. When we plug in n as 0 into the series, the first term a is 1. The final answer should be 8. 4 times 2. Right. Exercise problem. You can look at this problem. It's not geometric from here, but we can simplify. How to simplify? Two to the n plus 1 power, we can change this in 2 times 2 to the n power, right? And now we can take the 2 to the front, constant multiple rule. Now we get a geometric series, and we know the sum. Let's see. The first term is plug in n as 0, so it should be 1. and the ratio R should be 2 over 5 times final answer should be 10 third.